function. And we defined the conditional density distribution function using the same definition of the conditional probability function. So conditional distribution function of which is fx of x given b is nothing but the probability that x is less than or equal to b given an event b. And we know what this probability is by looking at the intersection between the two events x less than or equal x, small x, intersect with b divided by the probability of b. And we looked at the properties, and we mentioned briefly that the properties, all the properties of a CDF apply to conditional CDFs. And then we talked about the density function, and we mentioned that, okay, density function is the derivative of the conditional distribution function. So you just do the derivative. If you have discrete random variable, then if the conditioning will end up with step functions, then the conditional density function will have some impulses in it. And we also said that all the properties of a PDF applies to conditional PDF. And then we stopped here. So today what we'll do is we'll continue with some examples, and then we'll define the conditional density and distribution functions when you have a range conditioning. This is the objective. These are the objective of this class. Range conditioning that we'll talk about each other. So, any question before we go to the example, Isha? Okay. So we have in this example two boxes, small box B1 and larger box B2. Okay. Now these boxes have some balls in them. The number of red balls is 5 in B1, in box number 1, and 80 in box number 2, with total of 85. In box number 2, the green balls, you have 35 in box number 1, 60 in box number 2, in total of 95. The blue balls, 60 in box number 1, 10 in box number 2, with total is 70. So the total number of balls is 250, and in box 1 it's 10. There are 10 balls, and in box 2 there are 150 balls. Okay. Now, if I am interested in finding the probability, if I'm interested in looking at, I forgot to mention this, the probability that we select a ball from box 1 is 2 over 10. The probability that we select box 2 is 8 over 10. So one fifth of the time we select a ball from box 1, 4/5 of the times we select a ball from box 2. Okay, so this is basically the problem setup here. Now I can define the random variable here, x, defined as 1 if I select red ball, 2 if I select green ball, 3 if I select the blue ball. Okay, so this is the way random variable is defined. So as we mentioned before, the point of having random variable is to get away from the details of the experiment. So now we will not anymore talk about the color of the ball. We will talk about the value of x. So the random variable, the probability that x equals 1 given box 1 was selected, equals what? What is the probability that x equal 1 given box 1 was selected?
1.
We got, yes, نعم تفضل.
1 دكتور.
لا. Why 1?
You said we choose a ball from a box of ball. That's what I didn't understand.
Yeah, if I choose a ball, يعني خلينا نقولها كذا. Now, given that I chose a ball from box 1, okay? Given that I already selected box 1, what is the probability that x equal 1? How to find this? We go and translate what does the event x equal 1 mean in the sample space. What does x equal 1? When does x equal 1? We go to the definition of the random variable. When does x equal 1, Shabab?
When it's a red ball.
When it's a red ball. So what is the probability that I select a red ball given that I selected box number 1?
5/10.
5 over 100. Why? Because I have 5 red balls out of 100 balls in box number 1. Why I'm dividing over 100? Because it's given that I selected box number 1. It's given. It has happened. Already I know that it's box number 1. Now, given that, how many balls in box number 1 divided by total number of balls in box number 1, which is 5 over 10. Tamam? So in order to solve for this, usually, I translate the event of the random variable into what does it mean in the sample space, which is x equal 1 means the red ball. So here, 5 here, number of balls, number of red balls in box number 1. And the 100 is total balls in box number 1. Okay? Similarly, I can ask another question. What is the probability that x equal 2 given the same condition? Box 1 was
35
selected.
over 100.
It's the number of balls in box number 1 divided by 100. Excellent. So it's 35 over 100. Any questions about how did we find this?
No, easy.
طيب, ممتاز. So now, what is the probability that I not select? What is the probability that x equal 3 given b1? It's the number of, yes, it's basically x equal 3 happens when I select a blue ball. So it's 60 divided by 100. Excellent. So clearly, this is a discrete random variable, right? And hence, fx, which is the PDF, conditional PDF, of x given b1, it has 3 values, right? It's a delta at x equal 1 multiplied by the probability that x equal 1. So this is the probability that x equal 1 given b1. It's another delta at x equal 2 multiplied by the probability that x equal 2 given b1 also. So the condition stays the same all over. Plus a third delta at 3 multiplied by the probability that x equals 3 given b1. This is the way we write the conditional PDF. So this is a conditional PDF given b1. Now integrating this gives me the conditional CDF. So you have a step function at 1, multiplied by the probability that x equal 1 given b1. Another step function at 2, multiplied by the probability that x equal 2 given b1, and so on. Clear يا شباب؟
دكتور عندي سؤال.
تفضل. اي تفضل.
2 over 10 هذه how did we get it؟ مو بمفروض 2 على
this is given. هذه given. Excellent. And I told you the problem setup told you that the probability that I select b1 is كذا, or selecting b2 is كذا. If not given, then you always assume that they are the same, equally likely to select x1 or x2, box 2. If not given. If given, معناها you have to apply it. تمام؟
دكتور
تفضل.
ايش الفرق بين ال fx هذه small fx and capital fx؟
Wow, that's a big question. Excellent. Small fx is a PDF. Large fx is a CDF. CDF هي ال probability CDF fx خلينا نتكلم without conditioning. It's a probability that x less than or equal small x. Small x here is a variable, is a number, is a dummy variable. Dummy variable. Capital X here, and you see here is the random variable. يعني if I tell you what if x of 5, it's equal to the probability that the random variable is less than a number 5. Okay?
Yes, I know.
While
remember.
small fx is the PDF. It's the derivative of this function. Type other questions? So basically, this is the conditional PDF given or CDF given B1. Similarly, we can find the conditional PDF given B2. ايش رايكم يلا? What is this equal to?
80 over 150.
80 over 150 delta,
Delta
of
x minus 2
minus
or
1.
x minus 1
Yes. Plus.
plus 60 over 150.
طيب ممتاز. Delta
Delta x minus 2
plus
10 over 150.
excellent.
Delta x minus 2.
delta of minus 3. طيب عرفتوا يا شباب كيف جبنا هذه؟ The first one is the probability that x equals 1 given B2. Given B2, how many total balls I have to select from? 150 total. Given B2, what is the probability that x equal 1? X equal 1 means I select a red ball. It's the number of red balls divided by 150, which is 80 over 150. And so on. Any questions, Shabab? Now let's compare this with the non-conditional PDF and CDF. The non-conditional ايش يعني؟ يعني without telling you, without knowing which box I selected, I ask the following question. What is the probability that x equal 1? This is non-conditional. Okay, this is non-conditional PDF and CDF that we'll find now. يعني without making a condition that I select box 1, what is the probability that I select, what is the probability that x equal 1 أصلا? Well, in order to find this, we use what we call the total probability law. لو تتذكروه. اللي هو I find the probability of x equal 1 by conditioning over B1 multiplied basically this is equal to the probability that x equal 1. This is equal to probability x equal 1, which is the probability that x equal 1 intersect B1, right? Plus the probability that x equal 1 intersect B2. Is it? Why? Because B1 and B2 are what? ايش نسميهم؟ Mutually exclusive, that. ايش يعني mutually؟ معناها ايش؟ If I select B1 I cannot select B2. إذا أنا اخترت البوكس الأول ما أقدر أختار البوكس الثاني. Either I pick a ball from one of these boxes. And because of that we make addition here. Now the probability that x equal 1 intersect B1 is nothing but the probability that x equal 1 multiplied by, sorry, given B1 multiplied by the probability of B1. Probability of x1 intersect B2 equals the probability that x1 equal 1 given B2 multiplied by probability of B2. This is very important, Shabab, to understand how to apply this total probability law. Now, in order to find this, we just substitute. What is the probability that x equal 1 given b1? We already found it above.
5 over
5
100.
over 10.
5 over
5 over
100.
100. Right? 5 over 100. What is the probability that I select b1?
Given in the
given.
question.
2 over 10.
2 over 10. معلش سؤالك.
I said it's given. in the FS.
Okay. It's given in the question. Excellent. And the probability, now the probability that x equal 1 given b2. اطلع فوق نشوف. What did you given b2, what is the probability of x equal 1? It's this one, right? 80 over 150. Multiply by the probability of selecting box 2, which is b2. And
Given
this
in
is
the
given in the
question.
question. Excellent. So multiplying and adding gives you 0.437. Similarly, the probability of x equal to, you can write it in terms of probability of x equal to, given b1, multiplied by probability of b1, plus probability of x equal to, given b2, multiplied by probability of b2, similarly. And we can just substitute to find this as equal to 0.39. Similarly, probability of x equals 3 equals 0.173. So the PDF, the non-conditional PDF, the PDF of x, again, it's 3 deltas at x equal 1, x equal 2, x equal 3. The delta at x equal 1 equals with an amplitude of 0.437, which is the probability that we found here. It's the probability that x equal 1. 0.39, which is the probability that x equal 2. And 0.137 is the probability of x equal 3. And the CDF will be just the same but step functions. واضح يا شباب, how did you find all this? Any question? طيب الآن let us look at the shape of the PDF. Here we're basically looking at the PDF and the conditional PDFs. The PDF of X is the blue, and the conditional PDF is the red. Okay? Now, this is X. You can see that the blue curve, or the blue set of deltas, is the conditional PDF. This is the PDF of X, which is 0.437 at X equal 1, and 0.39 at X equal 2, and at X equal 3, it's 0.173. Okay? So you can see that the probability that you select, sorry, the probability that X equal 3 is smaller than the probability that X equal 1. بينما if we look at the conditional PDF given طبعا given the fx of x given b1, we're looking at given b1. At 1, it's small, it's 5 over, it's 0.05, 5 over 100. At 2, it's 0.35. And at 3 is كانت 60 over 0.6 basically. So you can see that given b1, the probability that x equals 3 is much larger than without giving b1, without condition. While given b1, the probability that x equal 1 is extremely small compared without conditioning. Why is that? Because you can see that the number of balls in B1 in box number 1 is very small compared to the total number of balls, and the probability that you select B2 is very large. So it's more frequent that you will pick B2, box number 2, which makes the probability of red or x equal 1 much smaller, much larger without conditioning. but with conditioning it's very small. واضحة الفكرة يا شباب هنا؟ What is the effect of conditioning? The whole distribution changes. Why? Because once I condition, the new sample space becomes that event B. Yani if I condition on B1, this is the new sample space. Without the 100. This is the new sample space. Without conditioning. With conditioning on B. When conditioning on B2, this is the new sample space. While without conditioning, the sample space is this total, of course, after taking the probability that selecting B1 and B2. Similarly, you can find the conditional CDF. This is the conditional CDF, the red one. So this is fx of x given B1. Why this is fx of x. 3-step functions, but the value of the step function is different according to the probabilities.
دكتور
تفضل.
هل ممكن تجي في الاختبارات ان رسم drawing for mapping
يعني الآن خلينا نقول في الأونلاين إذا كانت الاختبارات أونلاين يعني most likely no. But إذا كانت written of course you expect anything في written. لكن بغض النظر يا شباب عن الاختبارات يعني you need to understand the concept. أنت ما تعرف الفاينل كيف ممكن يجي لسه بدري على الكلام هذا كله. So my advice is study well and make sure that you understand every concept. ولا تفكر إن الأونلاين أسهل من البيبر ترى الأونلاين فيها بعد حركات. We can give you some nice exams. لكن please يعني make sure that you understand these things, how to plot, how to write, how to solve and so on.
It's easy, not difficult.
اي ممتاز ما هي صعبة أبدا سهلة. اللي خلص calculus 1
We did
و
it
calculus 2 this is nothing. ممتاز. طيب أي سؤال ثاني يا شباب؟
دكتور
تفضل.
for the PDF number 3 we get the lowest probability but why in the graph it is the highest?
x equal 3.
Yes.
النون كونديشنال هذه هي اللي هي 0.173. الكونديشنال الكبيرة اللي 0.6. الأحمر خلينا بس أمسح النقاط هذه عشان بس تبين. النقطة الحمراء هي الكونديشنال 0.6. النون كونديشنال النقطة الزرقاء هذه. واضح؟
Yes.
خليني أمسح النقاط هذه عشان أنا بس حطيتها عشان بس وأنا أشرح. ممتاز. أي سؤال ثاني؟ طيب الآن the other conditioning is the range conditioning. When we define the event B to be a range x less than or equal a specific number B, where B is any number, any real number. So now we are interested in finding the CDF of x given not a condition B اللي هو ممكن يكون رقم بس لا given x is less than or equal a specific number B. So given that x, the random variable, is less than a number B, what is the CDF of x? Now this is by definition equals the probability that x is less than or equal small x given the condition B is condition. تمام? And in order to find this, simply we apply what we know. Nothing is new here. It's the probability that of the intersection between x less than or equal small x intersect with x less than or equal b divided by the probability of the condition which is b x less than or equal to b. So this is given that the condition is possible. It doesn't have a zero probability. Okay. Now we have two cases here. Whether x is larger than or equal to b, or x is less than or equal to b. Okay. A relative value of x related to b. So when x is larger than or equal to b, what does this mean? It means that the event x less than or equal to b is a subset of the event x less than or equal small x. Why? Because b is smaller than x. B is included. Yani if this is a real line and this is b, we are looking at the range of x here. So the x is larger. So we are looking at the range of x that is here. So now the question is, given x is less than b, what is the probability that the random variable is less than small x? ايش رايكم؟
1.
1. Why? Because I
For sure
know
will
x is
be
less than b already, صح? I know that x is less than this value. So it is for sure less than the larger value. ولا لا؟ Okay? هذا logically. Mathematically, the intersection between x less than small x and x less than or equal to b is x less than or equal to b. This is the intersection because this event is a subset of x less than small or equal to x. And because of that, applying the conditional CDF, applying the conditional definition, اللي هو the probability of the intersection divided by the probability of the condition, gives you probability of x equal or less than or equal b divided by probability of x less than or equal b, sorry, which is equal to 1. واضحة يا شباب؟ Any question? Clear. Clear? Now, the other case is the opposite. When x is less than b. هي هذه الكيس. هنا is less than b. This is b and this is x. In this case, the opposite. X less than or equal to x is a subset of x less than or equal to b. المجموعة الجزئية انعكست الآن. So now, given x less than or equal to b, I need to find the distribution or the probability that x less than or equal to small x, which is equal to the CDF. طبعا now the intersection between these two events equals probability of equals x less than or equal to small x, which means the conditional CDF is written as the probability of the intersection divided by the probability of the event. Now the probability of the intersection equals the probability that x less than or equal to small x divided by the probability of the event. Now the numerator by definition is fx of x, right? And the denominator is fx evaluated at b, because we are talking about fx, so the p probability of x less than or equal to b, so which is the same as the CDF of x evaluated at b. So this is the number, huh? This is a function. We need to distinguish between them. هذا النمبر denominator is larger ولا smaller than 1؟ شباب.
Smaller than 1.
Smaller than 1, right? Smaller, less than or equal to 1. And because of that, this conditional CDF is always larger than or equal. This is larger than or equal fx of x. Right? And it's equal to, for x larger than or equal to b, it's equal to 1. And for x less than b, it's equal to fx of x divided by fx of b. So it depends basically where b is, you will have the different answers. تمام يا شباب؟
تمام.
أي سؤال؟ So basically conditioning باختصار يعني الآن conditioning always either gives you larger probability or at best the same probability. Probability cannot be reduced by conditioning. So probability cannot decrease with conditioning. ليش؟ لأنه conditioning إيش معناها؟ Conditioning means what? Means I am making the sample space smaller, right? خلينا نقول مش probability، خلينا نقول CDF distribution cannot decrease with conditioning. Okay? Let's see. Let's plot them. يعني خلينا ناخذ for general shape. If this is fx, this is the CDF. Okay? Then the PDF, then the conditional CDF هو fx of x given b, given x less than or equal to b. For larger than b, it's 1. For less than b, this is nothing but fx of x اللي هو نفس الكيرف هذا divided by a number that is less than 1. وهذا less than or equal to 1. And because of that, it's larger. واضح? And we have this equation. The conditional CDF is always larger than or equal the CDF itself. طيب شباب, clear? How did we find these things? We'll go into examples now, but any question about the derivation? The concept, the relation between conditional CDF and CDF. طبعا الآن conditional density simply differentiate. Now the same, given a range x less than or equal to b, the question would be what is the CDF, the conditional PDF of x given x less than or equal to b. In order to find this, I differentiate what I just already found above. لو تتذكروا ايش كانت ال fx of x given x less than or equal to b. كانت what is that? fx of x
على fx of b.
Yes. متى هذا? When x is smaller than b. And for x larger than b, كانت equal to 1, right? So differentiating this gives you the following. For x larger than b, larger than or equal to b, هذه هنا equality. For x larger than or equal to b, we have 1. Differentiating 1 gives you what? 0, right?
0.
Yes. And for x less than b, we had a function, a CDF divided by a number. The derivative of this function is known, right? It's the PDF. Divided by this number. نفس الرقم. هذا الرقم هذا constant. This is a number. This is a probability. Probability that x less than or equal b. It's a number. بينما الفانكشن of x is the above one, is the numerator. اللي هو its derivative is fx of x. PDF of x. Now, so basically the first part here equals what? Equals the PDF divided by the probability that x less than or equal to b, which is the integral from minus infinity to b of x dx. Again, similarly, the conditional density function is always larger than or equal the density function, always. طبعا this is for x less than or equal to less than b. For x larger than b, it becomes 0. So here we are plotting both. خلينا نتكلم على الجاوسن just for an example. So this is fx of x اللي هي الجاوسن distribution مثلا. Then fx of x given x less than b, given it's less than b, it cannot take any value here, and because of that it becomes 0. Given x less than b, then x cannot take any value larger than b. صح ولا لا؟ لأنه given it's less than b كيف تكون أكبر من b? And because of that we have a 0 probability. We have 0 here. We have 0. Now for x less than b, the result will be fx of x, the same shape, لكن divided by this number. So it's a larger, it's the same shape, the same PDF, except that it's larger. And this is given by this. Larger by the amount of fx of. So this is nothing but fx of x, نفس الفانكشن, divided by fx of b, which is a number again. I'm just أذكركم كل شوي إنه هذا رقم equals probability that x less than or equal to b. And because it's a probability, it's less than 1, and hence this is larger function. Any questions, شباب? Everything is clear?
إن شاء الله.
Let's have an example. The exponential distribution. Exponential distribution, random variable or density function, has this PDF اللي هو e to minus x for x larger than or equal to 0 and 0 otherwise. So it's 0 before 0 and it's e to minus x. So what is the average? What is the average? ال b value لو تتذكروها كم هنا؟ 1 كانت. If we substitute the density فوق اللي درسناها with b equal 1, you get basically this function. So this is the average value. b equal 1. طيب. Now the question would be, find the probability that x less than 1 given x less than or equal to 2. Okay? In order to find this, we can just apply the equation that we studied. This is equal, I will say this is equal to the PDF for the values x less than or equal to 2. It's equal to the PDF divided by اللي هي fx of 2, right? هذه nothing but fx of 2. And for x larger than 2, it's impossible, it's 0. Because given x less than 2, it's impossible that it has a value larger than 2. And because of that, for x larger than 2, it's 0. The probability, the conditional PDF is 0. واضح؟ Now we only need to find the first part. The first part is simple. It's the PDF, so it's e2 minus x divided by the integral of the PDF from minus infinity to 2, which gives you this. This is this, the integral. And this is only applied for values of x between 0 and 2. Before 0, we know it's already 0. For x less than 0, it's already 0, nothing. So nothing, يعني ما حيجيك هنا شيء because the original PDF doesn't have anything before 0. And after 2, x larger than 2, it's 0. It's 0. Because given x less than or equal to 2, it cannot be larger than 2. واضح يا شباب؟
والله واضح.
Other questions؟ طيب الآن let's calculate this. احنا إلى الآن جبنا بس البي دي اف، ها؟ الconditional PDF. We want the probability. هذا السؤال كان. The probability of x less than 1 given x less than or equal to 2. هذا كان السؤال. طيب. In order to find the probability now, simply I need to integrate the conditional, huh? The conditional PDF. Integrate the conditional PDF. هي ال F. So you don't integrate the original PDF. Why? Because I'm trying to find the probability that x less than 1 given x less than or equal to 2. So I integrate the conditional PDF, not the original PDF. واضح? Now integrating this conditional PDF from 0 to 1 is simply integrating e2 minus x. هذه هي conditional PDF لو تذكروا. It has only e2 minus x الباقي constants. So from 0 to 1, it's integral from e0 to 1 of e2 minus x divided by this constant, which is 1 minus e2 minus 1 divided by 1 minus e2 minus 2, which is 0.731. So given x is less than 2, the probability that x is less than 1 is 0.73. واضح? I want you to compare this with what is the probability of x less than 1 بدون conditioning. Find it for me, Shabab. Send it over the private chat. I want to compare this with the non-conditional probability of x less than 1. What is this equal to? Send me over the private chat. What is this equal to? So make the calculation and send it to me. Yes, Shabab. طيب Shabab, I only received very few. طيب Shabab, make it quick. طيب. So I see most of you have answered يعني correct. Some of you have, or they don't know. Some of you, some mistakes. طيب. So let's solve it together. طبعا this is whenever we ask a question, we need to do the calculation. We need to go back to the definition. So we don't guess, we don't assume. The probability that x less than or equal to 1, by definition, what is this equal to? It's the integral. احنا عندنا ال PDF. We don't have the CDF. So it's the integral from كم of the PDF dx from where to where يا شباب؟
0 to 1.
Yeah, PDF general from minus infinity to 1. For the general PDF, هذا general definition. Okay? For the specific PDF that we have, it's from 0 to 1. What is the PDF? E to minus x dx, right? So it's what? Equal to what? It's e minus e to minus x from 0 to 1, which is 1 minus e to minus 1. If you calculate this, how much do you get, Isiba?
0.632.
So now you can see that without conditioning, the probability that x less than or equal to 1 is larger, is smaller, sorry, than with conditioning. Because with conditioning, we have eliminated all this. It's eliminated. It cannot happen. Anything, any possibility above x equal to is impossible, given x less than or equal to 2. And because of that, we eliminated everything here. And hence, the probability, the conditional probability now is larger because the sample space is smaller. واضح؟ Any question? طيب, the last question is, or the example is the following. We have a target اللي هو within 50 meters. You can see the picture. And we have the bullseye, which is 10 meters. So this is the target. Anything that you get over this larger red circle is what we call the target. Anything that you get at the smaller circle, red circle, is what we call the bullseye. The bullseye is 10 meters. The target is 50 meters radius. Okay? Now the probability that the probability distribution, given you land on the target, sorry, the probability distribution that you fx of x, so if you make a shot, the probability that, sorry, the distribution that you get anywhere at the radius between 0 to infinity, is equal to this, or somewhere in between. It's equal to e to minus x, e to e x squared divided by 100, u of x. Time's up. So next time, inshallah, we'll continue. It will take several minutes to explain the concept. طيب, any question?
يعطيك العافية دكتور.
الله يعافيك. Time is up. Anybody who would like to leave, he's free to leave. Anybody who would like to ask,